A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, I was trying to think of a dish for dinner last night, and it hit me. Why do some ingredients just sing together, while others clash like cymbals drop down a staircase? Why does a squeeze of lemon make fish taste better, or dark chocolate pair so perfectly with coffee? Is it just cultural habit, or is there a hidden logic to it?
That's a perfect setup for today's prompt from Daniel. He's asking us to dig into the chemistry of food pairing, why certain foods are natural complements, and whether we can use that science to invent completely new dishes. And, fun fact for the listeners, today's script is being woven together by DeepSeek v3.2.
Little AI on AI action. So, is the secret sauce literally the secret sauce? Or is there a periodic table of deliciousness we've been missing?
It's closer to the latter than you might think. For a long time, food pairing was seen as an art, all tradition and intuition. But a much more scientific framework has emerged, really popularized in a book from a few years back, The Flavor Equation by Nick Sharma. The core idea is that flavor pairing is governed by shared volatile organic compounds. These are the aroma molecules that waft up into our nose, not just tradition.
So it's less about what happens on the tongue, and more about what happens in the nose. That seems counterintuitive. We think of taste as this tongue-centric thing.
That's the key. Up to 80% of what we perceive as flavor is actually smell. The basic tastes on the tongue: sweet, salty, sour, bitter, umami. They're the foundation, the simple chords. But the symphony, the complexity, the character, that's almost all aroma. And those aromas are carried by volatile organic compounds, or VOCs. Think of them as the individual musical notes that make up a chord. When two foods share notes, they harmonize. They harmonize.
Okay, so we're mapping foods not by food groups, but by their chemical signatures. That sounds like a job for a very hungry data scientist.
It absolutely is. This is where the concept of flavor networks comes in. Researchers, and now companies, have built massive databases. They use techniques like gas chromatography, mass spectrometry to analyze foods, breaking them down into their hundreds of constituent VOCs. Then they create these vast, intricate maps showing the chemical overlap between, say, a strawberry and basil.
Which, I'm told, is a fantastic pairing. So the hypothesis is simple. High VOC overlap equals harmonious flavor?
That's the food pairing hypothesis, yes. The idea is that our brains are pattern matching machines. When we taste two things with shared aromatic compounds, it creates a coherent, unified signal. It feels familiar and complete, even if the combination itself is novel. It's like your brain says, I recognize this scent profile from two different sources. They must belong together.
But that can't be the whole story, right? Otherwise, we'd just be eating dishes that are all the same note. Wouldn't that get boring? A dish of just strawberries, basil, and coriander might be too harmonious, like a song with no rhythm section.
That's the critical nuance. The similarity principle is powerful, but it's balanced by the complementary principle. That's where contrasting elements come in: texture, temperature, and especially the basic tastes. Fat needs acid to cut through it. Sweetness can balance salt, so the magic often happens in the interplay between aromatic similarity and gustatory contrast. It's the difference between a melody and a full musical arrangement.
Give me a classic case study. Something that seems weird, but the chemistry explains it.
The textbook example is white chocolate and caviar. On the surface, it's absurd. A sweet, creamy candy and salty fish eggs? But when you run them through the VOC databases, they share over 100 volatile compounds. That's a massive aromatic overlap. Chef Heston Blumenthal famously created a dish around this pairing, and it works because the brain is getting this incredibly rich, unified aroma profile, while the mouth experiences this wild contrast in texture and base taste creamy versus taste, popping, sweet versus salty.
That's genuinely wild. So the science can justify what looks like culinary madness. What about a more everyday pairing? Let's crack open the bag of salt and vinegar chips.
A great example. The sharpness of vinegar comes from acetic acid. Salt is sodium chloride. When you combine them, the sodium ions actually enhance the perception of the acetic acid. It's not just two strong tastes competing, they're amplifying each other. There's likely shared aromatic compounds in the malt vinegar essence and the potato as well, but the core synergy is a chemical interaction on the tongue that makes the whole thing pop more than the sum of its parts. It's a direct biochemical boost.
So if flavor is largely chemical, how do we map these connections? Let's look at the data. How is this actually being used? Is it just for fancy chefs with lab equipment? Or is there a practical application for someone like me, staring blankly into the fridge?
That was the case maybe 10 years ago, but the big shift is the democratization of this data. There are apps and websites now, like foodpairing.com or FlavorDB, that put these databases in the hands of any home cook or food developer. You can type in strawberry, and it will show you a spider web of connections to thyme, balsamic vinegar, even coriander seed, based on shared volatile compounds. It's like having a culinary cheat sheet based on molecular biology.
That's incredible. So a home cook can systematically experiment. Instead of just guessing that basil might go with strawberry, they can know it shares key compounds with, I don't know, lemongrass, and try a completely new direction. But how reliable are these tools? If an app says pineapple and blue cheese share a compound, do I just trust it?
It's a starting point for experimentation, not a guarantee of success. The databases show potential harmony in the aroma profile, but they don't account for intensity. One ingredient might have a trace amount of a compound, while the other is saturated with it. That's where the cook's intuition comes in, balancing proportions. But yes, pineapple and blue cheese actually do share compounds like esters, which is why that combo can work on a charcuterie board. The app gives you the why for the potential, and you handle the how much.
Now that we understand the science, let's see how chefs are using it to break the rules. What are the limits of the hypothesis, though? You mentioned Western cuisines tend to use pairs with high VOC overlap. What about other culinary traditions? Does the map hold up globally, or is this a Eurocentric theory?
That's a fascinating area of research. The original food pairing hypothesis was heavily based on analysis of Western, particularly European, recipes. When researchers started looking at East Asian cuisines, like Korean or Indian, they found something different. Those cuisines often deliberately pair ingredients with low AZ-OZOC overlap.
They're seeking contrast in the aroma profile itself, not just the taste. That seems like a completely different philosophy.
It appears so. The theory is that these cuisines are creating what you might call complexity through contrast. Instead of a harmonious blend, they're building a layered experience where different aromatic notes hit at different times. Think of a complex Indian curry with dozens of spices. You're not meant to perceive a single, unified aroma, but a cascade of distinct notes. So the food pairing hypothesis isn't a universal law, it's more of a strong tendency in certain culinary frameworks. The most innovative cooking today often plays in the space between these two philosophies, using the science of similarity to find surprising pairs, then applying the art of contrast to balance them.
That makes the whole thing less of a rigid formula and more of a powerful lens. So if I'm a food company trying to create the next big snack flavor, I'm probably mining these databases. But does that lead to genuinely good food, or just novel for novelty's sake combos?
Without a doubt, they're mining it. Look at the flavor trend reports from the Institute of Food Technologists. They talk about next-level experiences. That often means moving beyond obvious pairs. We've seen wasabi and dark chocolate, blue cheese and caramel, chili and mango combinations that might seem odd but have a solid chemical rationale. The algorithm suggests a pairing. Then product developers work on balancing the textures and tastes to make it palatable. The key is that the chemical overlap provides a foundation of plausibility. It's not a random shot in the dark. It's a targeted exploration of flavor space.
It's like a cheat code for innovation. But it also makes me wonder about the soul of cooking. Does reducing it to chemical overlap take the magic out? Are we just painting by numbers?
I don't think so. I see it as uncovering a deeper layer of magic. Knowing that a rose and a raspberry share a key compound called geraniol doesn't make a raspberry rose tart less delicious. It explains why that combination feels so intuitively right. It's like understanding chord progressions in music. You can analyze why a certain sequence is pleasing, but that doesn't diminish the emotional impact of the song. If anything, it gives you more tools to compose new ones.
Fair point. So, practical takeaways. If I want to play with this at home tonight, what's a good first step, beyond just downloading an app?
I'd suggest a simple experiment. Pick one ingredient you love and look it up on a public database like FlavorDB. Find an ingredient it's connected to that you'd never normally pair it with. Then design a dish around that pairing, but be deliberate about adding contrast. If both ingredients are soft, add crunch. If they're both sweet, add a pinch of salt or a squeeze of citrus. You're using the science for the aromatic core and your own intuition for the structural balance. Start small, a salad, a canapé, not a 7-course tasting menu.
I like that. It's a structured way to be creative. What about a classic pairing like wine and cheese? How does the chemistry break down there? That feels like the ultimate test.
That's a multi-layered masterpiece of chemical synergy. First, you have shared VOCs. An oak-aged wine and an aged cheese might both have lactose compounds that give coconut or woody aromas, so there's aromatic harmony. Then you have complementarity. The fat in the cheese coats the tongue, and the tannins and acidity in the wine cut through that fat, cleansing the palate. Finally, there's a physical interaction. The alcohol and acids can help release even more volatile compounds from the cheese, amplifying the aroma. It's a full-spectrum chemical duet that's been refined over centuries.
That's almost romantic. Now, what are the common misconceptions people have about this whole field? I imagine there are a few.
The biggest one is that this makes flavor purely objective and subjective taste irrelevant. That's not true at all. Your individual genetics determine your sensitivity to certain compounds. Think of how cilantro tastes like soap to some people. Your past experiences create preferences. The science provides the map of potential harmonies, but your palate is still the navigator. Another misconception is that molecular gastronomy is only for elite restaurants. It's not. Home cooks can now access the same databases and principles. At its heart, it's just understanding the why behind the what. It's knowledge, not gimmickry. Knowing why a souffle rises or why mayonnaise emulsifies is just as much molecular gastronomy as making spaghetti out of fruit juice.
And I suppose a third misconception would be that tradition is just arbitrary, when in fact, tradition often accidentally stumbled upon these chemical truths through centuries of trial and error. It was science without the lab coats.
100%. Grandma's apple pie with cinnamon worked because apples and cinnamon share cinnamaldehyde, a major volatile compound. Tradition was doing the science long before we had the tools to see it. We're just now catching up to the wisdom of the recipe box with our mass spectrometers. It's a validation of culinary heritage, not a dismissal of it.
Where is this all heading? If databases and algorithms are suggesting pairings, what's the next frontier? Are we heading towards fully AI-generated recipes?
I see two big frontiers. First is hyper-personalization. Imagine an app that knows your genetic taste profile, whether you're a super taster for bitterness or insensitive to certain cilantro compounds, and then filters the global flavor network to suggest pairings and recipes tailored specifically to your biology. The second is AI-driven creativity. We're already using models to generate scripts. It's a short step to training a model on VOC databases, recipe success metrics, and cultural preferences to propose entirely novel cuisine categories. An AI could design a 5-course menu based on the aromatic profile of a specific forest or a particular emotion.
An emotion-based menu? That's either terrifying or the future of fine dining. I'll have the nostalgia for a summer rain, followed by the tranquil contentment, please.
Probably both, but it underscores the point. This isn't about replacing chefs or home cooks. It's about giving them a new, incredibly powerful toolset. The algorithm might suggest the pairing of black garlic and dark chocolate, but a human has to decide how to present it, what texture to give it, what story it tells on the plate. The AI is the ideation engine. The human is the artist and executor.
It makes the culinary world feel both larger and more connected. Suddenly, a spice from one continent and a fruit from another aren't strangers. They're chemical cousins waiting to be reunited. That's a powerful idea for breaking out of creative ruts.
That's a beautiful way to put it. It's a framework that encourages exploration and breaks down culinary silos. Why shouldn't Indian spices work with French techniques if they share key aromatic pathways? The science gives you permission to experiment with confidence.
So, for the listener who wants to dive deeper into the why behind taste before tackling pairing, we did an episode a long while back, episode 147, called The Science of Taste: How Your Brain Creates Flavor. That's a great primer on the neurology behind all this.
Perfect recommendation. It lays the groundwork for understanding why these chemical signals matter so much. For today, though, I'd just encourage everyone to pick an ingredient and be a little scientific about it this week. Check a database, find a weird partner, and try it. The worst that happens is you order pizza. The best that happens is you discover your new favorite flavor.
And you get to feel like a mad scientist in the kitchen. Always a win. Thanks for taking us on that deep dive, Herman. As always, a huge thanks to our producer, Hilbert Flemingtop, for keeping the gears turning. And big thanks to Modal for providing the GPU credits that power this whole operation.
If you're enjoying these deep dives into the weird and wonderful, leaving a quick review on your podcast app helps other curious folks find the show.
This has been my Weird Prompts. Until next time, keep experimenting. This episode was produced using DeepSeek v3.2. Text-to-speech by Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from sloth, from man, from long-eared host. My weird prompts, until next time, stay curious, keep